And in this one, notice you have a quadratic here, and this is a quadratic, though it's a binomial, it's missing the constant term. Now, this expression here, this x squared plus x minus 6, this we can try and factor like we did above using that reverse distribution method, since the coefficient on x squared is 1. So let me just rewrite this. We have x squared plus x minus 6, and then this 2x squared plus 4x. Notice that in this one, they each share a factor of 2, and they each share an x. So we'll be able to use the greatest common factor for this one. So let's start with our quadratic. So you want to be careful because these don't always factor, but in these problems, a lot of times they will. So we're going to be able to factor this into a product of two binomials. So you can put in your spaces for two terms in each of these. And the coefficient on x squared is 1. So we know this has to be x and this has to be x, since when they multiply together, you'll get x squared. And we also know that the number terms here, whatever numbers we're adding or subtracting, they're going to have to multiply to negative 6. So we want to think what numbers could possibly multiply to negative 6. Could be 1 and minus 6, or minus 1 and 6. It could be 2 and negative 3, or negative 2 and 3. And so to determine which of these factor pairs we're going to use here, the last clue is that these numbers are going to add up to the coefficient on x. So a 1 in this case, a positive 1. So which of these numbers would add to positive 1? That would be minus 2 and positive 3. And of course, once you think you have an answer, double check by just remultiplying this out. And you'll see that you do get back this original quadratic here. Now from the second expression, the 2x squared plus 4x, notice that they are each divisible by 2 and each divisible by x. So we can pull out a 2x from each of these. And when we do that, we're just dividing. So 2 divided by 2 is 1, and x squared divided by x would just be x. So we pulled the 2 out, and we pulled one of the x's out. And then from this one, we're pulling the x out, so it won't have an x left. And then 4 divided by 2 is 2. So we could write the monomial out front. It doesn't matter. You can also put it in parentheses here. But a lot of times you'll see that written first as 2x. Then we have x minus 2, x plus 3, and x plus 2. And so this is what we'd put in our box here. So let's keep going. So this one, we're going to start by trying to factor out a common factor. So 3x to the 5th minus 75x to the 3rd. And notice that 3 and 75 are both divisible by 3. To check if a big number is divisible by 3, remember you can just add the digits, which is 12. And if that sum, after adding the digits, is itself divisible by 3, then you know that the bigger number is divisible by 3. Though, of course, you can always check with a calculator or long division. So we know we can pull a 3 out, and each of them have x terms, and this is the smallest amount, the x cubed. So we can pull out 3 x's from each of these. So when we pull out the 3, 3 divided by 3 is 1, and we took away 3 of the x's, so we'd have 2 left. And here we're dividing 75 by 3, or negative 75, which would be minus 25. And we pulled out all of the x's, so we wouldn't have any left. Now this right here, this x squared minus 25, this is what we call a difference of two squares. And when you have a difference of two squares, you could use the formula that this factors into a minus b times a plus b when you have a squared minus b squared. And you can verify that this is true by just multiplying out the right-hand side and distributing, but it is true. And so for a difference of squares, you just want to figure out what is squared in each of these. What is a and what is b? And in our case, we have 3x cubed. This is just x squared, we know. And 25 is 5 squared. So essentially, in our case, a is x and b is 5. So you're always going to get, if I just rewrite that first one, you'll get the first number minus the second number, ignoring the squares now. multiplied by the first one plus the second one. And of course, at this stage, you want to remultiply it out and make sure that you do get back what you started with. So the nice thing about these problems is that they're easy to check. But since there's so many different techniques, some of these can be a little bit challenging.